Hello everyone, this week I would like to demonstrate a new Forecast Forge feature which is about how to do cumulative forecasts. I've got a motivating example for that here. So here we've got some daily conversion data. Now these spikes are on the days that emails are sent. You'll notice that they're roughly weekly but not quite, roughly bi-weekly but not quite. That's a common thing in the real world where stuff doesn't quite always go the way you'd planned it. Now the interesting thing about this is that on this date here, which I've marked with a red line, they made some changes to the site. And we want to see if those changes were positive or not. So what we do with that is we use this data to forecast this period, and then we can look at the difference between what actually happened here and what the forecast says. And if those are far enough apart, we can conclude that the change made here is at least partly responsible for that. Now, we don't care too much about whether it's better or worse on any given day. Instead, we care about whether it's higher overall. For example, if you made a change that meant you got 100 extra conversions every Monday, but every other day you got the same or less, you probably wouldn't care that much. You'd think that was a good change because the total amount you'd have over the period would be different. And that's what the new feature is there to help you with. For example, if we made a daily forecast, then that would only tell us if it was different every day, whereas if we want to make a cumulative forecast. So I'll use the sidebar for this because I think it's slightly easier to see what's going on. We have our date range, which is a 2 to a 101, so 100 days worth of data here. The metric is in column B2 to B71, and we want the cumulative forecast to go there, so use the current selection. Now, the predictive interval width here is 0.8, which means that there's 0.1 below and 0.1 above. So I'm going to boost that up to 0.9, which means that if the prediction lies outside the predictive interval, there's a 95% chance that it is truly different because it's 5 below, 0.05 below and 0.05 above. So let's make the forecast. Okay, here we go. We haven't got our accuracy and errors because we don't have enough historical data here, but it's adequate for this. So we need to compare, so this is the cumulative total that we'd expect to see by day 30 of the test. So let's compare this with our actual. Just calculating the running total here. So we've got 3779, which is between our lower bound and our upper bound, and that means that in this case we wouldn't say that there'd been a significant change. A lot of people would reject this and say it was a null test. However, recall that there's big variance in the time series here caused by when these emails are sent, and Forecast Forge doesn't know that that's what's going on. It just sees these as a random change, which means that it expects just random changes to happen in the future, which is why we have a wide interval here. What we can do instead is we can add in the dates that emails were sent as a regressor column. So you see that's this column here, where I've got a 0 on days when no email was sent, and then a 1 on the days when these particular emails were sent. So I can add this in as a column, a regressor column, and then we'll rerun the analysis. So just click make forecast again. It will run the forecast, and there we go. So we've got 3551 as the lower bound and 3598 as the upper bound, and our actual was 3779, which is higher than the upper bound. So we know that whatever happened, whatever change was made on this day, had a positive effect overall. And this is the same process that you might have seen people use with an R package called CausalImpact, except here you can do it in your spreadsheet and you don't need to be able to code. That's all for this week. Thanks for listening.